So in our last video here regarding cross products, we're going to try to give ourselves a little bit more of a visual representation of how we can calculate the cross product of two vectors, get those components. And so we're going to take advantage of how to find the determinant of a 3x3 matrix to help us out. So what we have here is, and if you're not familiar with matrices, it's not too bad. It should still be something that's useful for us. But if you are, it'll be a little bit helpful. But anyway, what I've done is, in the top row of the matrix, I've put just the I, J, K unit vectors. In the middle row, I'm going to put the components of the vector A, so I, J, K order, X, Y, Z order, then likewise for B. So I'm going to go ahead and set that up for myself for these two vectors that I see here. So I have I, J, and K. I've got 6, -5, and 2. And I've got -7, -4, and 6. And so then, how do I find the determinant of a 3x3 matrix? Well, the way we do that is we're going to eliminate the column and row, first row and first column. And so in the overlapping location there is I. And so that's what I have right here. And then what's left behind when I eliminate that row and column, I have a 2x2 matrix right here. And so I'm going to find the determinant of that 2x2 matrix. And the way you find the determinant of a 2x2 matrix is you just multiply the diagonals and subtract them. So I'm going to multiply AY times BZ, that's this first diagonal, that's what we see here. And I'm going to subtract the other diagonal product, BY times AZ. And I can see that right here. So down below, what that means is, if I, again, eliminate the first column and the first row, I'm going to undo that just so that we're not distracted by that later. But again, we have this kind of lower right-hand corner as our 2x2 matrix. So I'm going to multiply -5 times 6, and then subtract -4 times 2. And then again, that's times I. So I've just done this part right here. And if we continue on, we're going to get -30, and then minus -8, so plus 8. So we're going to get -22 as our I component. And so hopefully that rings a bell from that example. The same two vectors that we found the cross product before, we got the same result. So then we continue on with the formula. And again, I'm going to do a little erasing here, because now I'm going to cross off that same top row, but now I'm going to cross off the middle column. And so then the overlap of those two is the J that's under there. So that's what I see right here. And then if we just kind of mentally eliminate that central column, I have a 2x2 matrix left behind again. And so then I need to find the determinant of that remaining 2x2 matrix, and that's exactly what I have here. A x times bz is going that way, minus bx times az on the other diagonal product. And so I'm just subtracting those once again and then multiplying it times j. The one catch that I have here is that this is now a subtraction symbol. In our other formula it was addition, but also in our other formula, if you look back at our notes there, this subtraction was reversed as well. So just when you're finding the determinant of a 3x3 matrix, we need it to be minus there. So I'm going to go ahead and continue and do all of this work here. So I'm going to have minus. So I'm going to, again, just pretend like that middle column there is missing. I'm going to undo that again so that we're just not distracted by it. So I'm going to go 6 times 6. So one diagonal minus -7 times 2, and then that's times j. And again, you'll notice I have the subtraction there. So if I carry this through, I'm going to have 36 minus a negative, so plus 14. It's going to give me 50, but then that's being subtracted, so we're getting minus 50j. And so that's again the same value that we got the last time. And so to close things out, I'm going to do that same process. I'm going to go back up here and erase one more time. And now I'm going to eliminate that top row again. Then I'm going to eliminate the last column. So in the overlap is K, so that's what we have here. And then I have this 2 by 2 matrix that's left behind, plus, this time, AX times BY minus BX times AY. We can see that here. And so then again, referring this time, I'll go ahead and cross it off because we don't need to see it anymore. I'm going to have plus, well, I guess I can go over here, plus, we're going to have 6 times negative 4 minus negative 7 times negative 5. And then again, that's times K. So we're going to have a negative 24 minus 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 once more is going to be minus 35. So if we combine those, we're going to end up with minus 59K. So this is the exact same result we got at the tail end of the last video. It's just now, instead of having had to memorize the various multiplications and subtractions to get these components for I, J, and K, we have this visual approach that we can take. Eliminate the top row and the first column, multiply the 2 diagonals, and subtract. Do the same thing, top row and the middle column, same thing for the end. The only difference here is we have to have that subtraction symbol in our formula to get the right positive negative sign on the middle. But otherwise, instead of having to memorize, we can use this kind of eliminate the row column approach of the 3 by 3 determinant to help us calculate the cross product components of A cross B.